Hello, I'm Jocelyn and I'm a physicist, but I'm also a longtime dungeon master and the owner of possibly too many dice, possibly too few, depending on what my players are up against this week. Now, dice are such an important part of Dungeons and Dragons, not just because they're really important mechanically, but also they're such a fun aspect to the game. Like, it's such a great time to be rolling a handful of dice, or the fact that they're just colorful and clicky. Dice are great, but dice are also pretty cool if you think about them in a mathematical sense, because dice are in geometric shapes, and those geometric shapes are actually pretty fundamental and have a lot of really cool properties to them, even to the point where there is a scientific historical reason to associate throwing a ball of fire with throwing a whole bunch of D4s at someone. I'm going to talk about all of that and more on this episode of Fiction. To learn more about dice geometry, we have to start looking at what the actual shape of the dice are, which in geometric terms is called a polyhedron, where polyhedron means poly, many, and hedron, which basically means it's a 3D shape. Unlike a polygon, which is what we call a 2D shape. So polyhedra, like the D20, is made up of a whole bunch of little polygons. In this case, a whole bunch of triangles. And the interesting thing we can see, if we start to look at the kind of usual set of 7 Dungeons & Dragons dice, is that there is something that 5 of these have in common. Besides the percentile dice, which are both 10-sided, every single one of the normal set of D&D dice are all made of the exact same shape, and each of those shapes have all the same sides. We've got a whole bunch that are made of equilateral triangles, and then 2 that are made up of squares, and another one made up of pentagons. Now, these are really interesting because these are what are called regular polyhedra. And what regular polyhedra means is exactly what I described, which is that all of the side lengths, the angles, everything is all the same. But why is that the case? Actually, it makes a lot of sense. If you think about what we want out of dice, one of the first things we want is for it to be easy to make. And so if all the sides are the same, it's a lot less of a pain, because otherwise you gotta do weird, funky molds, which are doable, and I've seen them to be done, but if you want it to be something for a lot of people, all the same shape, much easier, because we also want it to be fair. We want to have the same chance of getting any side. If you've ever seen one of those huge D100s, they're pretty wonky looking because they've got to make all the kind of shapes different, but it still has to have the same chance of rolling on any of them. It just gets kind of weird and then goes against the whole easy to make thing. The last thing we really want out of dice is for them to be able to roll. That's a big fun part of the dice. If it weren't that, then we could use like a top, which would work, but that's not what we want. We want dice, and dice are supposed to roll. Now, what does it mean to roll? And for this, we can kind of look at what is the difference between the D10 and something like the D20. When you've got the D10, if it is on one of the faces, it's going to be way harder to push this D10 across this middle part, the shorter end, than it will be to push across one of the sides. Which means if you try to roll the D10, it just kind of ends up on one side and then flops around. Versus something like the D20, every single side, it's just as easy to push it over. And that's because all of the sides are the same length. So if we limit ourselves to wanting shapes with just the same side lengths, we limit ourselves to the regular polyhedra. But how many of those are there? Because it seems like we should be able to have a whole bunch more dice. If we want to expand our dice set, what are other shapes we would want to bring in? If you think about it, polygons which are the 2D shapes, you can go as big as you want. You know, you can start off with triangles and cubes, but you can have 20-sided shapes, you can have 100-sided shapes, you can have as infinitely many until you just kind of get to a circle where it's all just flat. But are there infinite regular polyhedrons? Polyhedra. This is a really interesting thing about geometry. So let's just try it. If we're gonna start, we gotta start with the simplest shape, the triangle. What happens if we put 2 triangles around a vertex? Well, you don't have a shape because it's just kind of a flap. Next step up, 3 triangles around a vertex. And what does that give us? Our D4. The D4 is known in geometric terms as a tetrahedron, where tetra is from the Greek prefix meaning 4 because it has 4 sides. You might be familiar with the prefix for tetra from the video game Tetris, because each of the tiles, the kind of game pieces in Tetris, is made up of 4 squares, hence using the prefix tetra for 4. If we move up to keeping with the theme of 4, putting 4 triangles around a vertex, we get our D8, which is known as an octahedron, which it might not be surprising from octopus and octagon, means 8, because the octahedron has 8 sides. Octahedrons also have some other cool properties. If you ever see a natural diamond, they are often actually in octahedral form. And this is for kind of a cool chemical reason, because if you want to pack together different shapes, one of the kind of efficient packings is to do alternating octahedrons and tetrahedrons. It's known as tetrahedral octahedral honeycomb, which is also kind of fun if you ever get sick of building dice towers while you're waiting for things to happen. Try doing tetrahedral octahedral honeycomb packing. It's a little different, a little unique, and some cool chemistry. If we then move on to doing 5 triangles around a vertex, we have the most famous piece in the game, the D20, or the icosahedron, where icosa is the Greek prefix for 20, because 20-sided. Another kind of cool thing you can actually do with an icosahedron, though, is what happens if you cut off every vertex. Essentially, you slice it so that you now have a new shape there, and you get a whole bunch of hexagons and pentagons, and this is known as truncation. And what you get if you take a truncated icosahedron is a soccer ball, which is kind of neat. So the D20 is related to sports. What happens then if we try to put 6 triangles around a vertex? That doesn't go so well. Or it does, depending on your definition, but it's a hexagon. A hexagon isn't ever going to make you a 3D shape because it's just flat. That's just going to be a tessellation. If we try to fit 7, it's now getting convex instead. Which means it's going outwards, which means you're never going to be able to make that into a closed 3D shape. Which means we've reached the end of the number of shapes we can build with triangles. We only got 3, and all 3 of them are D&D dice. Okay, that's it for the triangle. On to the square. With the square, we get something we are pretty familiar with, the cube, which could technically be called a hexahedron because it has 6 sides. But no one ever calls it a hexahedron because cubes are so used for so many things, we needed a simpler name for it. I mean, can you imagine if every time you saw a box, you went, hey, look, it's a hexahedron? Yeah, that wasn't really gonna happen. And as you might have guessed, the cube is where it all ends with the square. Because if you try to put a bunch of squares, if you try to put 4 squares together, you're just making floor tiles. More than that, you're not ever going to be able to close it. So the squares didn't get us very far, or they did, considering how useful the cube is. But still, only one polyhedron. The last shape, spoilers, the next shape we look at is the pentagon, where a pentagon has 5 sides, and if we put together pentagons, we get the dodecahedron, or the D12, because dodeca means 12. Yes, polyhedron are not very creatively named, but that's math. The dodecahedron, honestly, I feel a little bit bad for it. People have not really done much with it for a long time. Maybe because no one really once you get to pentagons, no one really likes them. They're hard to draw. Usually they come out looking like houses instead of actually being regular pentagons. Even ancient Greeks kind of shafted it, but also it kind of got a special role as well. So maybe it's not all that bad for the dodecahedron. And even now, the dodecahedron at least got a rather starring role on the Dungeons & Dragons show Critical Role. So maybe it's not too bad for the dodecahedron. But it is the last of the shapes we can make with our pentagon, because if we try to put more than 3 pentagons around a side, it's again going to be convex. So we can't make it into a closed shape. That means we move on to the hexagon. But we've already been here. We were here with our triangles. Hexagons, they tessellate. You're just going to get a whole bunch of hexagons next to each other, and you're never going to make a shape. And as we know, if you try to throw more in, like put 4 around a side, it's never going to close. Same thing with 7, with a heptagon, which is a 7-sided shape. Never going to close. And so on and so forth. We have reached the end of the shapes we can make out of regular polygons. There are only 5, and every single one of them is a D&D dice. These 5 polyhedra are known as the Platonic solids because Plato did a whole bunch of stuff with them. He actually wasn't really probably the person who discovered most of them or their properties or anything, but he was a very famous philosopher and he got his name attached to it. That is not new and also continues happening in physics and math and a lot of things. So we've got the 5 Platonic solids, which are all Dungeons & Dragons dice. There are some very cool things about the Platonic solids. Not just the fact that they are shapes that fit all of our criteria for dice, and the only shapes that fit those criteria. There's also some pretty weird stuff about them. Now, back in the time of Plato, philosophers had a lot of different ideas than we kind of have realized are true today. One of those things is that they thought that everything around was made up of 4 elements: earth, air, water, and fire, which is still a big thing in fantasy today. But because there were these kind of 4 fundamental elements, when they found that there were only these so many shapes that you could actually make out of regular polyhedra, they started associating those polyhedra with the elements. So Plato actually said essentially that fire was made up of D4s because, they're sharp and pointy, as anyone who has ever stepped on one of them would know. So of course, that's fire. Air, on the other hand, was supposedly made up of a whole bunch of octahedrons, or D8s. Water, could flow, so of course it was made up of the roundest of the Platonic solids, the icosahedron. And then Earth, it's all nicely packed, was the cube. The cool thing is, this means that you can talk about chucking a fireball at somebody as just chucking a whole bunch of D4s at them. It is equally scientifically accurate and historically accurate as anything else in fantasy. You might have noticed that there are 4 elements, but 5 platonic solids. Again, our poor little dodecahedron has gotten kind of left out. But not quite. In ancient Greece, there was also kind of this idea of a 5th element, which was ether. Just kind of this mysterious substance that made up things like space. So the dodecahedron, as its little mysterious self, got to be space. It got to be the heavens. A dodecahedron really move it up in the world. And physicists and mathematicians have continued to be obsessed with the platonic solids because there is something so beautiful about shapes that are all the same. They're so symmetric. Everything just looks nice and works. And that's oftentimes what, we're looking for out of the universe. We want it to be beautiful. We want it to all work together. And not just that, but every day we all want that. That might be why we're still so attracted to the idea of these pretty little dice that are such nice shapes. The last thing, though, to talk about is the less nice shape, the D10. The D10 is the only one of the dice that is not a platonic solid. Why might that be? I can't tell you for sure, but probably the fact that we have a base 10 system of counting because we have 10 fingers and 10 toes, so we needed a 10-sided die, and we'd run out of platonic solids. So we took the next best thing, something that maybe doesn't roll that well, but it works, and we can use it to roll percentages, which people definitely do all the time in Dungeons and Dragons. You know what I mean? So here we are with all this cool geometry that we can get out of our fun little math rocks that we use to do Dungeons and Dragons. There's a lot more beautiful geometry to be seen, but that we can work out in another video of fiction. Thanks so much for watching. Have a great day.